This is lesson 6.1, and we're going to talk about perpendicular bisectors and angle bisectors. So perpendicular bisector, if you recall, is when it's perpendicular to a line and it cuts it in half. So the midpoint is one of the points on the perpendicular bisector, and it's a right angle. So we have the perpendicular bisector theorems. If a point lies on the perpendicular bisector, then it is equidistant from the endpoints of the segment. So if I know CD is the perpendicular bisector of AB, I now know that AC and BC are equal. And the same thing could be said in reverse. If I know there's a point that is equidistant from the two endpoints, then I know that that point is on the perpendicular bisector. So our first thing in here, we see that we do have a perpendicular bisector, the right angle. These two segments are congruent, which now tells me these are the same. So if I want to find the value of x, I will set 7x plus 24 equal to 13x minus 48 and solve. So we end up with x equals 12. Similarly, here I know that C is equidistant from A and B, meaning C is on the perpendicular bisector, which tells me that these are the same. They do want me to find AB when I'm done, so I'm going to start by finding x, and I'm going to plug it into one of them and double it. So we'll start with 5x minus 11 equals 3x plus 17. And we end up with x is 14. So if I take that x is 14 and I plug it back in here, 3 times 14 plus 17, we get 42 plus 17, which is 59. So if this is 59 and this is 59, AB is really 118. So you can go ahead and try these two. Pause. When you're ready to see the answer, hit play. All right, so for the first one, we end up with x equals 2. For the second one, we get x is 3, and after I substitute it back in for RS, I get 17. Next, we have segment JK is formed by J and K. We want to determine if point L lies on the perpendicular bisector. So we need to check that J to L is the same as K to L. And to see if these two are the same, we would use the distance formula. So JL in the distance formula, we're going to do -7 minus -9, which turns into -7 plus 9. And we do -8 minus 2. So this is a positive 2 squared. And this is a -10 squared. Positive 2 squared is really 4. -10 squared is really 100. So this is the square root of 104. And I could leave it like that. Now I'm going to check KL. So that's going to be 1 minus -9, or 1 plus 9, and 4 minus 2. So 1 plus 9 is really 10. 4 minus 2 is really 2. So this is 100 plus 4, which is also the square root of 104. So yes, L lies on the perpendicular bisector of JK, since JL equals KL, meaning L is equidistant from J and K. You go ahead and try this one. Pause. When you're ready to see the answer, hit play. All right, so we're checking QS and RS. We get the square root of 82 for both, so yes, because QS did in fact equal RS. Then we have our angle bisector theorems. So an angle bisector is a segment, line, or ray that cuts an angle into two congruent pieces. If a point is on the angle bisector, it will be equidistant from the sides of the angle. So the segments that are perpendicular to the sides from that point will be the same. And the reverse is true. If I see a point that is perpendicular to both sides and those are congruent, that makes that the angle bisector, and I can set those angles equal. So in this example, I see that I have an angle bisector. These are the segments that are perpendicular, so they are congruent. So we're going to have 9x minus 5 equals 4x plus 30. And we end up with x equals 7. This one didn't ask us to plug it back in, so we're done there. All right, this one, we know that these segments are perpendicular. And actually, we know the triangles are congruent. We could prove that, which tells us these segments are congruent. Oh, I don't know what I'm doing here. I'm sorry, people. I'm looking at the picture backwards. Okay, we are given the two angles here. Because point I is equidistant from the sides of the angle and perpendicular, I know these two angles are the same. So I'm going to set those equal. We get x is 19. They want me to find FGH, so the whole thing. So I'm going to plug it back into one of these. Let's say I did 2 times 19 plus 20. So that's 38 plus 20. That's 58 degrees. So each of these angles is 58 degrees, which means the entire angle FGH is 58 plus 58, or 116 degrees. So go ahead, try the last two. Pause. When you're ready to see the answer, hit play. I'm looking at these and I realize that those are not the right pictures. So that's going to be a bit of a problem for you. So let's try this again. So don't look at the answers right now. Okay, try these two, pause again, and then check your answer. Okay, so for the first one, we would get x is 3, and when I plug that back in, AD is 35. For the next one, I get x is 7, and I'm plugging it back in for angle XWZ, so just this one here, the 8x minus 32, and I get 24 degrees. And that is section 6.1.